Hello everyone. In this video we're going to learn about unions of sets. To start us off, we're going to have a definition, and I'm going to describe two sets. Let's say A is some set, is any set, and B is any set as well. He could be the same set, he could be a different set, he's anything he wants to be. So these two guys are some sets. And I'm taking A union B. And this U symbol is what we use to denote unions. Kind of see it with unions, the U. So when we want to find the union, we define it to be the set of all the elements, let's call them X because I'm unsure of what the elements may be, such that X is an element of A, and the symbol that I drew right here means element. It just means the fancy word of saying it's an object inside the set A. Then we're going to use this beautiful word called OR. X is an element of B, and that's the end of that set. So that's the union between the two. Now, it's best explained with graphical means. So I'm going to draw a Venn diagram. And actually, I'm not going to draw. The program's going to help me. Oh, no, it's not going to help me. Undo that. Ugh. Let me get another oval. There we go. So there's a shape, and here's another one. And what I've drawn here is the set A, and here's the set B. And now I've made a cruel assumption here. I'm assuming that A is overlapping B, or B's overlapping A, whichever way you want to swing. Now these are two sets, and I'm going to find the union of A and B. I'm sorry, A union B, or we could say A or B. And what that means, if there's an element in A, that's part of the set, so I'm shading it in. If there's an element that's in B, say X, then we also want that part of the set. And even though these two overlap each other, that shared region they both consider together, so A union B is the total shaded region here. Everything's included in the union. So the shaded part here shows A union B. Maybe you're still like, okay, that doesn't make much more sense. Okay, let's try another way to think of this. Let's say the set A, and I'm going to define it because saying he's anything is kind of a little crazy. Let's say he's the set of 1, 2, and 3. 1, 2, and 3 are the elements, objects inside of the set A. And the set B is, let's say, 2, 4, and 6. And I want to find A union B. So what I'm going to do is figure out if there's an element in A, he's part of the union. Go back to our definition. Let's just quickly sneak back there. So A union B is defined to be all the elements, all the objects, where they're in A or they're in B. And the picture we've drawn is says, okay, all of A, all of B, if they overlap, we don't double count. So when we look at this, we have the objects 1, 2, and 3 inside A, so they're part of the union because everyone's included. We got 2, 4, 6 that's in B, so we include those. Oh, 2's already included, so don't need to double count it. And there's the union of A and B. So if you wanted to see this picturally, let's go back to those horrible Venn diagrams I drew, and let's just try it again. Let's say we have set A, and I'm going to use the same set A from earlier. We had 1, 2, and 3. So I'm going to kind of just float the numbers, and this is set A. Then I got set B over here. And set B included 2, 4, and 6. And that's set B. Now the union between these two, it's either in A or it's in B. So you got to start getting of that word or. I have a bad habit of trying to say and it's really improper because and means something else. So it's A or B, or they both have it simultaneously. And now we're looking at this. The union shades in everybody, right? Everybody's included in the union. Everyone's happy. So we have the set of all these elements. And notice 2 overlapped here, so we don't have to write it twice. It's unnecessary and repetitive. So there's the union. I hope that cleared up a little bit of confusion. And now in the next video, we'll do intersection. So until next time.